Yeah. Okay. Around 20. So, dear students, we are going to start the new chapter for you. That is the first chapter of chemistry. Chemistry. That is the atomic structure. You see, that is atomic structure. Atomic structure. So atomic structure the hello दीपक मुझे व्यस्त अच्छी तुम परिवर्तन कर बुझल मुझे ମୁଁ ଏକାଟା ଯାଇ ଘର କରୁଥିଲି ଏକାଟା ଏକା ହେଲା ଆଉ କଣ କହିଲେ ଦେଖିଆ କଣ ହଉଛି ଯାଇ ଦେଖା ହେଲା ବୁଝା sorry so atomic structure so it deals with the study of structure of atom so what is an atom so let us so what is an atom? What is an atom? Before going to define what is an atom, let us remember what you have studied earlier. Means Dalton's atomic theory you already know. There are 2 points in the Dalton's atomic theory. What are those? An element consists of a large number of minute or tiny particles called as atoms. And second point is atoms are indivisible. These 2 things were the main points in the Dalton's atomic theory. That atom is the smallest particle of an element. Atoms are indivisible, means not divisible. But this fact was proved wrong after few years of Dalton's atomic theory, that atoms can be divisible. Means atom contains still fine particles such as electron, proton, neutron, like that. An atom consists of 60 number of fundamental particles or subatomic particles. Out of those, only 3 are important to us, that is electron, proton and neutron. So atom, now we can define what is an atom. An atom is the smallest. An atom is the smallest particle of an element. An atom is the smallest particle of an element which takes part in a chemical reaction. Which takes part in a chemical reaction. So this is what we mean by an atom, or we can define the atom like this. Another thing is that an atom may or may not have free or independent existence. Free or independent existence means there are some elements whose elements can exist independently or freely, whereas there are some other elements whose atoms cannot exist freely or independently. So, what are those elements whose atoms exist freely? Now they are atoms of metals, atoms of noble gases, which exist freely. But there are some other elements like fluorine, chlorine, bromine, iodine, hydrogen, oxygen, nitrogen, whose atoms do not exist freely. So these are some basic ideas. So so these are some basic concept or basic idea about the atom what I have given to you. But we are interested. But we are interested how an atom has been composed of. Structure of atom means how the atom has been composed of. What are the fundamental particles of an atom? What are the basic constituents by which an atom is formed? Those things we will discuss now. Electron, proton, neutron. These are the main fundamental particles by which an atom is composed of. Now let us see how the electron was discovered. Let us see how the electron was discovered. Discovery of electron. Discovery of electron. Electron was discovered by J.J. Thomson in the year 1898. So electron was discovered by J.J. Thomson in 1898 from discharge tube experiment. What is a discharge tube? Let us see. What is a discharge tube? So discharge tube, you see, a discharge tube consists of a long hard glass tube, made of glass. So this is a long hard glass tube made of glass. It consists of two metallic plates. You see, here is one metallic plate. Here is one metallic plate. So this is the metallic plate I am taking. Another metallic plate is fitted here. This is another metallic plate. Now this metallic plate like this metallic plate is connected to a source of high voltage. Means we are going to connect the two plates in the discharge tube to a battery which can provide electricity or which can produce a current of high voltage about 10 to 12,000 volts. So this is your negative terminal. If this plate is a negative electrode, you can say that is your cathode. So this is your cathode. And this is obviously the positive plate, and it is called as anode. So this is negative end, this is positive, negative, positive. So like this. This is a battery used for producing high voltage of electricity. Now this is the outlet connected to vacuum pump. In this discharge tube, we have to take a gas at a very low pressure, so that current can pass through these gases only at a very low pressure. Because of that, we have connected here vacuum pump by which the air can be removed. The pressure can be made very low inside this. So whenever it is anode, it is your cathode. Inside one gas is there. When a current of high voltage was passed through this gas, means battery on, when it is on, the plates are being charged. So the gases inside the tube are also gaining some electrical energy. In gases, you can take any gas, hydrogen, oxygen, fluorine, any gas you can take inside the tube. The gas, hydrogen, suppose hydrogen gas is there. Hydrogen molecules are there. Hydrogen molecules contain two hydrogen atoms. So first of all, these hydrogen molecules break down into hydrogen atoms, and the electrons in the hydrogen atom gains energy, and these electrons are knocked out from the atom, and it is seen that some rays are produced from cathode are traveling towards the anode. These are the invisible rays. Which we can't see. We can't see them. Then how can we know that some rays are produced there? So for that, For that, some phosphorescent material is coated here. Phosphorescent material is coated here. Phosphorescent material is coated here. Say of zinc sulfide, ZnS, zinc sulfide. One phosphorescent material is coated here on the walls of the glass tube. When these rays strike here, some bright spots were seen here. So from that, it was confirmed that some rays are coming from cathode side and traveling towards anode. Since these rays coming from cathode side and traveling towards anode, these rays were called cathode rays. These rays were called cathode rays, and they are being attracted towards anode plate. Means they contain some negatively charged particles. So this is the point. These rays contain negatively charged particles. Those negatively charged particles were later on named as electrons. Means these rays contain electrons. So cathode ray contain electrons and travel from cathode side, from the cathode plate towards the anode. Now, once again, I will tell you the experiment. Just I am repeating. We are taking a discharge tube. In that, we are taking a gas. The gas is maintained at a very, very low pressure. So for that, a vacuum pump is here to create low pressure inside the gas. After that, when high voltage is applied here, nearly 10,000 volts is being applied. Then the gas molecules break down into atoms. Then the atoms, by gaining the electrical energy, ionizes. Means electrons are removed from the atoms, and those electrons are a stream of electrons flowing from cathode side to the anode side. Those rays are called as cathode rays, and it contains negatively charged particles, which were later named as electrons. So this is how the electron was discovered. This is how the electron was produced or discovered by J.J. Thomson from discharge tube experiment. So this is your production of cathode rays. Production of cathode rays. Now, one more thing I can say. The confirmation of cathode rays were made by using a perforated anode. A perforated cathode means the cathode plate. The cathode plate. This is your cathode plate. Okay, this is your cathode plate. A perforated anode was used to be confirmed about the flow of rays from cathode plate. So how it was? Now perforated anode was made like this. You see, this is a plate. It contains some holes. So the rays, again the same experiment was repeated, and the rays passed through these holes, like that, and struck here, and some bright spot was obtained on the phosphorescent material coated on the walls of the discharge tube. So this is it. By this way, the rays produced from cathode and moving towards anode was confirmed. When the discharge tube experiment was repeated by using a perforated anode. Holes are there, that's why it is called a perforated anode. Now, we will discuss now very important properties of cathode rays. So, properties of cathode rays. Properties of cathode rays. Number one property: cathode rays move in straight line. Cathode rays moves in straight line. How it was confirmed that these rays move in straight line? When an object was placed in between the cathode plate and anode plate, its shadow was produced. So from that its shadow was produced. So from that it was confirmed that rays are passing in a straight line. Cathode rays moves in straight line. Number two, it contains negatively charged particles known as electrons. Why? How it was confirmed? It contains negative charge particles. Now, when these rays were subjected to externally applied electric field, suppose we are applying one electric field here. Say for example, I am taking a anode plate here, I am taking a cathode plate here. Now, the rays were, suppose it is now my anode plate, it is now cathode plate. Suppose it is externally applied electric field. This is the arrangement what we have made earlier. It is also there. But when externally applied electric field is there, anode and cathode plates are there, it was observed that the electrons, the rays were attracted towards the anode plate. So these are the electrons. They are attracted towards the anode plate. So it was confirmed that cathode rays contain negatively charged particles, which we call them as electrons. Number three. When a pedal wheel was passed, when a pedal wheel was placed in the path of these rays, one wheel was placed in the, when wheel is, some blades are there, one wheel was placed like this. Then when the rays struck the pedal wheel, the wheel rotates. So it was concluded that the rays contain some massive particles. The rays contain some particles. Those particles when struck here helps in the rotation of the blades of the pendulum. Blades of the pendulum. So it was rotated. So it was concluded that cathode rays can rotate. Cathode rays can rotate a pedal wheel placed in its path. So these are some properties of cathode rays which I discussed with you. Cathode rays contain electrons, and the discovery of the electron was made from cathode ray discharge tube, but this is called discharge tube experiment, from which cathode rays were produced, or we can say the electron was discovered. Oh, thank you all. In the next session, I will tell you about the discovery of a rotor. Thank you all.